이번 발표는 슈나이더일렉트릭의 오스왈도 크시니 부사장님께서 글로벌 스마트 그리드 트렌드에 대해서 발표를 진행해 주시겠습니다. 오스왈도 크시니 부사장님은 변전소 및 배전 자동화, AMI 등 전력사업 분야에서 30년 이상 활동을 하고 계시고 현재는 스마트 그리드 솔루션 개발 및 지원 등 전력사업 부사장으로 재임을 하고 계십니다. 오스왈도 크시니 부사장님을 뜨겁게 맞이해 주십시오.
I would like to thank very much the organization for inviting us to come here. I am representing 슈나이더일렉트릭 in the global organization. I have all my life been working in the electrical utilities, being in several countries from US, Middle East, and now I am 5 years in France. And I think it's a good opportunity that we can discuss about the challenges and the trends that we see in terms of smart grid. We all know that things are changing and we need to speed up this change. We have a very smart world today when we talk about communication, when we talk about technologies, we talk about ICT. Korea, to me, it's a very good, let's say, example where these new technologies can be tested, can be implemented. It's a very developed country with a lot of huge industrial park, and we see that we need to improve our efficiency, our grid, from the traditional grid to the new, what we call a two-way flow of energy, communication, connectivity, and integration. When we look at this, our energy matrix, we see that this graphic we try to show the renewable energy. If you look at the last 40 years, we can see up to 6 times more affordable renewable energy, including the photovoltaic, the PV, the solar thermal, the wind. This is clearly a big trend that will continue, and we think that the effects of that will be to help to preserve our future in terms of the quality of life. When we look at the challenges, we see that the demand is increasing. When we have the demand increasing, we are talking about two types of two sets of countries. I think when we say smart grid is a very general word. Most of us have different interpretation of a smart grid. And we have conventional technology that are there for a long time, and this is related, including transmission, distribution, conventional, let's say, intelligence that is placed in the system. We have countries where we still have a long way to be able to provide energy to the people. We see Africa, we see India, we see the big demand that is very strong actions in China. And in other words, the demand, it is continue to increase. This is the reality that we see here. When we try to look at the total equation, the integration of renewables, it brings a lot of investments that we need to do to make the come back here. One more. To make the system stable, the integration of renewables bring a lot of challenges. This change in the energy matrix does not come for free. And one of the actions we need to take is related to the demand when we are talking about peak, and that's what we're going to try to show. We see that the growing cost of energy, it is forecasted in the next 40 years, we will spend more than what was spent in the previous 400 years. The problem that we see very clearly that there is a misuse, or we have a mismanagement of our resources. The cost, the underutilization of our generation and our resources, it causes us a bigger cost that leave us to several problems. Here we list 6 of those. The issue that all of us, we know very much that we need to provide the peak demand with the sufficient generation. And when in the conventional grid, we would have continue to having a lot of investments in the generation for underutilization in terms of a general generation, because we are only trying to match the peak that are for few hours. The shift of the peak, that it's a big opportunity to postpone big investments in generation, as many countries are already doing this with advanced management systems and advanced solutions. We have the issue that is a constant concern, the pollution. Just as an example, in January this year, we had an issue in Beijing. There was the air quality index reached 800. The maximum allowed is 500, or recommended is 500. The government took actions, shutting down factories, restriction of traffic, and so on. But at the end, the problem is the basic energy generation that is based in carbon fuel. And China is a very good example. We were talking during lunch. It's today the number 1 in the renewables, with even the amount of solar farms that are being included in the country. The traffic congestion, the statistics are showing that in the last 5 years, the congestion in Europe and big cities in Asia, they doubled. This morning it took me 1 hour and a half to come from the other side of the city here, and this is a lot of energy that we are losing. And the climate disorder, I don't need to talk only about this superstorm Sandy that was a kind of Fukushima issue that happened in US in last year. These are being caused by the climate. Few years ago, we were talking, our scientists talking about the warming because of the CO2, of forecast of 2 degrees Celsius grow up to the end of the century. Today, this number is already 4. In other words, the CO2 emission needs to be taken in consideration as part of our needs. The water, the water scarcity, it's also a huge concern. We already have this in some regions where we need to do desalination plants. This happens in the Middle East and other areas in the world. And this requires big amount of energies. And we cannot only continue adding capacity, adding generation. We need to improve how to use that energy, to reduce the use of energy with more efficient solutions and systems, energy efficiency. Then we don't want to cook the planet. There was a say that the world is something that we need. We don't want to leave to our children, but we borrow from them. In other words, we need to take the actions now to improve this, to have less effect, and to use energy more efficiently. There are two ways or two schools of thought. One is to consume green, to have a very strong push for the renewables, mainly solar, wind, and so on. And the other is the focus in the low carbon thermal plants, like the shale, using the shale gas. And we believe that at the end, what we need is a combination of a cleaner generation, greater efficiency, it's a huge space on that area, and a smarter grid. On this, in this graphic here, we just show for 2020 the contribution of efficiency, and for 2035 we can see that the contribution to reduce the CO2. I'm talking about what are from those 5 actions here, with the renewables, with the biofuels, the nuclear, carbon capture storage systems. These are the percentage that is impacting the reduction of CO2 for 2020 and for 2035. For 2020, it's very clear, over 70% estimated reduction can come from the energy efficiency. I read news here, like in Korea is an example, where the government is taking many actions related to demand management and to improve the energy efficiency. Only 5% of the Korean, let's say, industrial and the big users of electricity energy here, they are with the programs implemented for energy efficiency. We believe, as one of the players in this energy game, that we can improve the energy efficiency from the industry to the buildings to the homes, up to from 30% minimum up to 70%, depending on the process. And that is a big need that we have. I was reading also, as an example of energy efficiency effect, there was a very recent report for US. In the United States, in the last 4 years, the additional capacity of generation that was added to the system from 2010 to 2013, 35% of that capacity came from large-scale renewables, big PV, CSP, and wind farms. 21% came from what we call distributed energy. That includes demand management, to be able to optimize the curtailment of loads, to shift the peak, and so on. To include also the energy efficiency and the local or distributed generation with the residential solar. That is the first time that I have seen that big country like US that has developed, has added generation capacity with more than half not being conventional generation. Less than 50% was from conventional generation. This is a big example of how much space we have. We are talking, like in this case, 21% that we call for energy efficiency plus demand management. This can be also applied and can be increased in other markets, in other geographies. Then we need to build a new energy efficiency. We need to have a very clear view. What are the consequences of what we are talking? If 70% of the reduction, the contribution in reduction of CO2 by 2020 and 50% by 2035 comes from energy efficiency, it's a big opportunity to do that. We can say we have the studies that were made, like including by 2035, if we follow that approach, we would have about the equivalent of 230 gigawatts of coal fire and 120 gigawatts of gas-fired power plants could be offline if we implement those energy efficiency programs. And that should be a priority for all of us, for all the different regions. When we talk about the smart grid, we say that 4% of the global emissions, between 60 million metric tons to 200 million metric tons by 2020, can be reduced in CO2. The impact of smart grids in this study is around 4% of the global emission in terms of CO2. The energy efficiency, for sure, as we said, is to reach what as a part of this sustainable approach. We want to have energy reliable at the right cost. We want to have a comfortable home, a nice work environment, as well as the industries that we have the capability to deploy this energy efficiency program in an order that we keep that desire, that role, what we want to do, using less. And with this, we have this concept that was launched. We talk about megawatts. That is the megawatt that we are able to save. And the energy efficiency is this simple equation where we have an OPEX optimization and a reduction of CAPEX. We can postpone a lot of investments, multi-billion investments, doing this better management of our grid with energy efficiency, demand management programs, and so on. The energy efficiency, for sure, we are talking also about the connection between the IT or ICT, actually, and the energy. And the technology is available. We have the technology to do that. We are able to build this equation and to improve the efficiency of our consumption. When we look at the word, I said in the beginning, smart grid means different things to different people in different countries. We have different regions with different needs that we will show in the following slides. But at the end, we need to have the match of the supply and demand, and this is becoming more and more difficult. Inserting the renewables, it is not a predictable power generation, and we need to reinforce the grid to be able to have a stable system. I was also reading recently that even in Japan, the government has decided to slow down the integration of solar based on the needs of huge investments in the grid to keep the system reliable. There are here on this slide, I try to list here the recent events that we have changed let's say the priorities and the strong penetration of renewables, for instance. In Japan, it came from the Fukushima accident, the nuclear accident. We have countries like Germany and other countries where this is a very important issue to prevent nuclear. I think even here in Korea there was some intention to raise the nuclear participation in the energy matrix, but there is a lot of questions and oppositions related to the nuclear safety. The other thing is related to the electrical vehicle. I am part of the European Commission working group, couple working groups, and I remember when we were in 2010 initial discussion, there was a forecast of about 4 million electrical vehicles in 2015, and the reality is being very different. It's still going very slow, and that is another thing that changed a lot, because the electrical vehicle, it is a storage that when we talk about millions of vehicles, you can help to improve the energy balance. The issue of in Europe, we see here like less sensitive feeling about the CO2 than those aggressive programs in terms of CO2 that we mentioned before, and they are being pushed back or slowing down because of the social issues and because of even what they call the credit, environmental credit in Europe is being reduced. The other reality is the smart metering. The smart metering, we have geographies, we have places like in Germany that they don't still have the business model that would justify the investment of the smart meter based on the benefits that it can bring. We have a very strong renewable in Europe push, as you know. In Germany today, it's already more than half of the German capacity in terms of power. It comes from renewables, and about 28 to 30% of the demand, it comes from renewables. But there are issues is how are we going to be able to change the business models, because when we have net zero or positive energy homes and buildings, we have less customers to share the cost of the assets of the utility. And this is something that the utilities need to start to think in different business models where they can be more load management for the smart home than to be simple supplier of energy. The last item here that we are talking, it's about the gas technology. With the shale gas, we have the low carbon. This is impacting also the metrics and the development of power generation and availability. In the world, when we talk about priorities, things are very different for region to region. On the North America, we have the issues with a very aging infrastructure. We have the issue of these big disaster and events. And the main aspects that are looked in the smart grid are the demand response, demand management, the increase of the distribution automation with volt VAR management, and the energy efficiency, as I mentioned before. When we look at Europe, we are going to more and more to the deregulation, distributed generation. And with the deregulation, we have the competition to get the customer, the integration of the renewable. And this brings the big question of reinforcement of the grid, big investments that we need to do in terms of renewables integration. We have a very initial, let's say, pilot or demonstrator for electrical vehicle management in some pilot projects. That's in case of Europe. For Asia, we have a growing demand that comes mainly from China. There is a huge push in the automated metering infrastructure with the smart metering. The distribution automation, again, when we have the renewable integration, as I mentioned, we were talking today, China today and Japan are the largest producers of renewable with the solar, in terms of the solar energy. This is a change. Until recently was US. US now is the third one. We have very different realities for South in India, for instance. Half of the population, or almost half, does not have energy. Their concern is not the efficiency, energy efficiency. You have big losses. The government launched big projects to reduce losses. The average was around 45% in many places, many cities. They had a $400 billion program to improve this in about 70. It's underway, this program, since 2011. About 70 large cities in India. But it's a long way to go. I had one colleague that was in Africa last month, and he was in countries where you have less than 10% of the people with energy. We are not talking about the basic needs that are not satisfied. We have in South America different concerns, and this is related to the growing consumption, as we said. The needs there are still related to the basic grid modernization, and the energy efficiency is starting. It's still behind of the Europe or the mature countries. Then, in the two blocks that we talk about, mature countries, that we include Europe, West Europe, North Europe, plus Asia, including for sure Korea, Japan, Singapore, and so on. And in North America, the concern is to have more efficient demand management programs, the consumption side solutions to provide better and reduction of the load of the consumer. When this, I'm not going to have time, but you have access to this. But basically, it shows here for the different topics of the smart grid for the different regions, what are the priorities. And this varies. And then we don't have one solution that can be applied. It has to be tailored. There is an idea, for instance, for demand management launching in Korea, that it will be specific. It's a very industrialized country, and then you need to have some specific characteristics to be successful. We believe that 슈나이더일렉트릭 has been moving in the last 8 years to be a big player on this energy dilemma. We have been moving from, let's say, product transactional company with acknowledge high quality systems and equipments to a solution provider. And two large investments that were made in the last 7 years, 8 years, we are able today to provide end-to-end solution coming from the generation optimization. Coming from the generation optimization to the plug, to our house plug. We are able to bring in Invensis, that was the latest acquisition of Schneider in the beginning of this year. We have the capability to dispatch the generation, several different types of generation, from thermal to hydro to wind and so on, nuclear. We have already done projects like that where we have the best dispatch of those units to reduce the impact in CO2, for instance. the social responsibility, and also the limitations in terms of operation. In the grid itself, this is the traditional area where we are positioned in the supply side. That means this is in the power. Here is in the supply side. We have all the solutions from products, equipments, software, systems, solutions, services, and so on. In the big movement also that we have done is in the demand side. We have acknowledged, we have many projects that we are able to have the efficient, to provide to the customers the needs of an efficient home, to industrial, to the efficient, to improve the efficiency of the industries, to have a much better use of energy, to also shift and shave the peak. We have implemented projects in Duke Energy where the driver of the project was to postpone additional generation of multi-million investments in generation, being able to shave down and to shift the peak around 9 to 10% of their load or the demand. And this is an example of acting as a complete energy management system from the utility to the end customer, to the industry, to the building, and to the residential. When we talk about the smart utility, we are talking about four main areas. That the grid part that we already discussed, where we have the full solutions to provide the best management of the grid. In the consumer side, or on the load side, we have also all the solutions for the demand response programs, the microgrid. We have, as was already presented this morning, many projects in the storage, with the microgrid being part of, or storage being part of integration of renewables, as well as part of the microgrid projects. In Europe, there are 300 islands, around 300, not connected to the continent. There's some projects, very interesting projects to improve that. They usually have thermal generation with a lot of pollution and CO2, and they have added the renewables, and we are helping them to provide a full energy management system that is able to optimize and to use as much as possible renewable generation, reducing the impact of pollution and CO2. On the generation, we called here, we say the smart generation with the optimization of the generation. And on the renewable, we have all the solutions, what we call the balance of plant, the BOP. We don't make turbines or generators, and also as well as we don't make the loads, so we don't make the appliances that consume the load, but we are able to provide an end-to-end solution in order to optimize, to have the best efficiency in the use of energy. In those four areas, we have the specific actions in the specific different solution portfolio that it is in your copy of the presentation. And basically the idea here is to provide lower cost of operation. We want to have energy to use it more efficiently. We want to reduce the CO2 to help to reduce. We want to have a shift of the peak. We have this as a priority. We want to have a lower cost of operation and less investments in capex. This is the focus, and I think this trend that we discussed in this presentation it is suitable to this kind of approach, where we are able to provide tailored or adjust solutions to different geographies. I'm not going to go. This is just a quick slide talking about product, solution, service, and partnership. We have partnerships in many of those important regions, like here in Korea. We are starting a partnership for the management program. On the innovation, Schneider is a company with 25 billion euros revenue in 2013. We have about 5%, over 1 billion euros in R&D, in innovation, covering these different areas that we are talking here, from the substation, from the grid itself, from the management, from the software, the integration of renewables, the microgrid, the storage, and so on. In other words, the challenge we have, I think, to conclude, the challenge we have is that how can we improve the efficiency of the use of energy? And this is something that will affect our planet. There is a huge space to go. And to me, the energy efficiency is the most, the quicker response we have for the next decades. And all those programs that are promoted by the different governments are very important to test the technology. And we need to go to implement this to have a real advantage of the smart grid. When we talk about smart grid, we are talking about what we can give better to our population, to the world, and to the future. Thank you very much. This is just the last slide that we are trying to show that we have solutions in the most different places. That is the Arctic station, that the energy management is provided by Schneider in a very remote situation. In other words, we are ready to partner with you, with the different players in this energy transition or the new challenges we have. Thank you very much for being here, and I'm very happy to participate in this Smart Grid Week in